Good riddance. All right. Um, cool. So I already made the float, by the way, so I don't forget. Just kidding, Becca. Yeah, so check out Amethyst's Twitter thread. Really helpful stuff, and we're actually gonna try and make it like a official resource after the boot camp is over. All right, cool. So it's 10:02. We're gonna get started here. Just a little side note. Today is actually not that hard, so we're sort of winding down, which is a little nice. And yeah, so let's get going. Welcome, Numini. Good to see you in the chat. All right, and oh, we have Big Daddy Iraq too. What's up? Okay. So we're gonna start off with chapter 5. We're already on chapter 5. Wow. We only have one more chapter to go. We have today and Friday, and after that we're gonna be all done. So today we're gonna start with chapter 5, day 1, pre and post conditions. Let me share my screen. I forgot to do that. Welcome, hi. Good to see you. Hi. So I shared my screen. So yeah, today we're going to be talking about pre and post conditions and events, which is actually, it's not that hard of a concept, so I believe you should all be good. And Becca, even though you haven't been in the course for a while, this will still apply to you because this doesn't really relate to any previous knowledge. So Becca, you can definitely learn something today as well. All right, so let's just dive right into it. You can read this chapter if you want to, but we can also just go to the playground and have some fun in here. All right. So what the heck are pre and post conditions? Well, they are basically like requirements that you can put on functions in order to make sure that something is true. So what do I mean by that? Well, let's go ahead and make a function called add, and it's going to take in an x, an integer, and a y, which is also an integer. All right. And inside of here, right, what we're going to do, we're going to say this, this function adds x and y together. Okay. And then maybe we're going to like return the result, right? So x adds x and y together and returns the result. So if we pass in, 2 and 3, it's going to return 5. So we can say return x plus y, right? Super easy, okay? But what if we want to make sure that x and y are certain things? Well, one solution we could do is to say, if, like, let's say, let's add a requirement where we want to say that x has to be greater than 5 and y has to be, I don't know, greater than 1, okay? So, like, these are arbitrary. Like, I'm just randomly saying this for this example. But let's say we only want to be able to call this function if x is greater than 5 and y is greater than 1. So what we could do is we could say, okay, if x is less than or equal to 5, then what we want to do is panic and say this is not good, right? That's one thing we could do. And remember, the panic keyword is basically means just abort the whole program, reset everything, and just get out, right? That's one thing we could do. And then we could also say, okay, well, if that didn't happen, then if y is less than or equal to 1, then we also want to panic and say, panic, this is not good. Okay, so this is a really ugly way of doing this. And it's also it's just it's an ugly way of doing it, pretty much. There's a better way to do it, and the better way to do it is with something called a precondition. So we can add a precondition here, just like this. You put pre, and then you put little brackets here, and inside this precondition, you can put a bunch of requirements that must be true, otherwise it's going to panic. So what you can say is x must be greater than 5, and if it's not, well, we can say x is greater than 5 and with the double and symbol, so and y must be greater than 1. And if it's not, we say, sorry, x must be greater than 5 and y must be greater than 1. Very simple. Okay, so just to recap, what this says is x must be greater than 5 and y must be greater than 1. And if this is not true, then it will print this. So sometimes people get confused and they put like the anti-condition here. Like they put like if y is greater than or is less than, or like they put the thing that's like not supposed to be true, but you have to put the thing that's supposed to be true. Okay, so if we want x to be greater than 5 and y to be greater than 1, then we put those two things here. And then if it's not that, then we print this. And so behind the scenes, what this actually is a panic. So even though we don't like put panic here, that's actually what this is saying. So let's go ahead and deploy this contract, and let's go to a script and see what happens. So let's return. Let's let's go to import hello world from first account, and let's return hello world dot add, and we're going to pass in 2 and 0. So exactly, the precondition must be true. So who thinks this is going to work, right? If x is 2 and y is 0, is this going to work? Who thinks it's going to work? Not work. Okay, and so why is it not going to work? Any guesses? Oops, Becca was strong about that answer. X is not greater than 5. Exactly. Great job, NG. So that's awesome. Yeah, Becca. Yeah, I know you're so excited to be in this academy with me. Trust me, I get it. So yeah, so it's not going to work, right? So let's say we execute this function. Uh-oh, precondition. Sorry, x must be greater than 5 and y greater than 1. So if we were to change that and make it 10 and I don't know, 15 or 165, whatever, if we execute this, then we return the value. Oh, it added them. Perfect. We did it. So a precondition is something that must be true. Well, we can actually write this up here. So a precondition is something that must be true before we run the function, right? So this precondition is run before we do anything in here. So if we were to do anything in here, it would run before all this stuff, okay? Cool. Now we move on to postcondition. So as I'm sure you may be guessing, a postcondition is something that runs after. So a postcondition is something that must be true after we run the function, right? So you may think that you put the postcondition down here, but you don't. So it's actually it's tricky. You actually put the postcondition up here. So I'm gonna get rid of the pre just for simplicity and leave the post here. And so even though post is up here, please keep in mind that this is running after the function's over. So even after the return value, okay? So one really cool thing about the post condition is that we can actually check the result of the return value. So what we can do is, let me scroll down here so I can show you where it is in the notes. Where is it in the notes? Right here, result. So there's a special keyword called result. And what result means is it's actually the return value. So we want to say, you know what? We want to make sure that the result is greater than 100. All right. And if it's not, then we're not going to allow this to work. So the result must be greater than 100. And if it's not, we're going to say, sorry, the result must be greater than 100. All right. Cool. So what this is going to do is it's going to call the add function. It's going to skip this. It's going to go into this part, do anything that we put in here. Then it's going to return x plus y, and then it's going to check the post condition. Okay, so let's redeploy. We deployed it, and so if we go into our script, if we were to run 10 and 165, it's going to work, right? Because these two are added together are greater than 100. But if we made this one like 15, it's going to fail and say, sorry, the result must, and then of course the playground's buggy, so it's not giving us the full error, but you get the point, right? Cool. And for the record, you can put both as well, right? You can put both. And if you want to list multiple, what you would do is you would say like x is, if you want x and y to both be greater than 100, you can say x is greater than 100, and y must be greater than 100. Otherwise, do some error message. But just to show you, if you wanted to list two things, you could say x is greater than 100, enter, and then y is greater than 100. And these are both, it's the same exact thing. So it'll check both of these. So if you want to, you can split them up because then you know exactly what's wrong. Because in this one, you could say x must be greater than 100. And in this one, you can say y must be greater than 100, right? You can, specify your errors a bit more. Cool. So one more thing I want to tell you about. So one more thing, yeah, is the before keyword. So, full like spoiler alert, I've pretty much never in my life ever used the before keyword, but it's worth mentioning anyway. So in the post condition, not only do you have access to, can you go X, Y, Z greater than 100? Yeah, so you could do anything you want. So if we added like a Z variable here, you could check Z if you wanted to as well. That's totally fine. you could say like x greater than 100, and y greater than 100, and z greater than 100. Yeah, that's totally fine as well. So one thing I want to tell you about the post condition also is that not only do you have access to this result keyword, you have access to a keyword called before. So let's add a variable here called public var number is an integer, and we're going to initialize the number 0. Okay, so it's 0, and we're gonna change this whole function. So this function is now just going to be called increment, increment number. So the entire purpose of this function now is just to make number go up by 1. That's literally it. So inside here, it's not even going to return anything. It's not going to return anything. It's just going to say number or self.number equals self.number plus 1, right? It's super simple. So what we can do in the post condition is we can say before self.number equals self.number minus 1. Otherwise, we didn't increment correctly. So what this is saying is before is a keyword that means the value of the thing in the parentheses, so self.number, before this function was even run. And then this self.number is referring to after the fact because we're in a post condition. So under post, I'll say, result is a keyword that points to the return value, and before is a keyword that represents the value of something before the function was even run. Okay, and so this function will always succeed because self.number is always going to increase by 1. So just by the nature of that, the before value will always be 1 less than the resulting value of number. Okay, cool. So does that make sense to everybody? The before keyword? Super awesome. That's great news. Cool. Awesome. Thanks for the confirmation, everyone. So one more thing I will mention is that remember what I said that this is basically like a panic behind the scenes? Well, remember what we know about panic. If it's called, it will revert everything and abort the program. So I have a question for all of you. If I put minus 10 here, right? So this is my post condition, okay? And I call increment number, right? So I deploy the contract, number is currently 0, and I call this function, what will the value of number be after I call this function? And why? Great job. Great job. So see, Raven got it right and Amethyst with the correct explanation. So the resulting value of number will be 0. Because what it's going to do is it's going to call increment number. It's going to add 1 to it. So now it's currently 1. And then it's going to go into the post condition. This is going to fail. So it's going to panic, abort the whole transaction, and number is going to go back to being 0. So that's an important point. Awesome. Boom, you did it. Cool. Okay. So that's that. Yeah, so that's everything about pre and post conditions. And actually, if you want to ask, like, you're probably asking, well, like, when are we ever going to use these? I'll show you what, like, you could just use these whenever you want, but there's actually a reason for them, and we're going to talk about that later in this lesson. So just keep in mind, like, how you do these and what they're doing, but we're going to go over, like, a much more clear example of, like, when you would actually use them later. Okay. So the last thing we're going to talk about is events. All right, so in events. So events are, I guess to take a step back, when you're inside of a contract and something happens, right, it's hard to tell the outside world that something actually happened. Now, what I mean by this is, let's say you have a contract that mints an NFT. The only way that like an application, like, like a marketplace, for example, would know that an NFT was minted is if they like call the script to see how many NFTs existed and then at some random later point, called another script to see how many NFTs existed again, and just check to see if they were the same number. And that, obviously is not a solution, right? Because that basically means that you can't ever know if something happens. Um, this is where events come in. And I can't stress enough how important events are, and not that many people correctly implement them. So that is why I'm here to try and teach all of you. So events are ways for your contract to tell the outside world that something happened. And this is really, really, really important, especially with NFTs, because when your NFT is minted, it's traded, it's claimed, it's transferred. You want the outside world to know about that so that applications can track your code and understand where your NFTs are living. So, for example, the entire reason a marketplace knows that something is listed for sale or that something has been sold is through events. It's because they track events. So how do you make an event? Well, you say public event and it's always public. So it's never like access contract or anything. It's always public. Public event, let's just say like mint NFT, right? So I'm going to delete everything. I'm going to delete this. I'm going to make an NFT resource called NFT. All it has is an ID in it. And we're going to initialize it. This is just setup. All right. I don't know why. Okay. Cool. And then we're going to make a function called mint NFT that all it does is return an NFT resource, or mint it and then return it. Cool. So what we're gonna do is when someone mints an NFT right here, we want to know an NFT was minted. So we're gonna make an event called mint NFT, and we're gonna put a variable in here called ID. So we want to know which ID was or which NFT was minted. Now the thing about this is that the variables that you put inside these brackets, these are what other applications outside your contract will know about your event. So, for example, if we had like a name in here too, string, we could put let's pass in a string here and say name string self.name equals name. And we're going to pass in a name here as well. Pass that along. Wow, there's a lot of steps. But there we go. So now our NFT is also going to have a name, right? And so what we can do is inside our mint NFT event, let's also put a name so we know the name of the NFT. And right before we return this NFT, what we're going to do is we're going to say, okay, instead of just returning it right away, let's store it inside an NFT variable. Then let's emit. So emit is a keyword that actually like sends the event out to the public. So emit the mint NFT event. The ID is going to be nft.id, and the name is going to be nft.name. And then we can return the NFT back. Okay. So now, when your NFT is minted, we're telling everyone on the blockchain, hey, an NFT was minted, notice me, okay? And so a live example of this, if you want to see a real example, is the floats page. So if it's working, we got some note that it wasn't working earlier because Flow mainnet was having some issues, but hopefully it starts working again. But if you've ever visited the live float page, you'll probably have noticed that floats fly up through the screen, right? And the way it's doing that is we actually send an event out called float claimed, and we use this service called Graphel. So Graphel is a really awesome tool, and Graphel will take all those events, put them in a dictionary, and then send them to your application if you want them. So we actually work with Graphel because they will take all the float claimed events, put them in like a little storage, and then send that to us. And then we display them on this page. So of course it's not working right now, but I'm not sure why it's not. But I'm sure you've seen this page before. I think another good example is .find. Let's see if it's working on here. Live feed. If it works. Maybe Graphle's just. Oh no, here it is. So you'll see that it says powered by Graphel right here. So this is a live feed of all the names that are registered, listed for sale, registered, listed for auction. All of these are coming from events. right? Graphel is sending the event data to .find, and they're reading it into their application. Awesome. So let me actually show you where that's happening. Let me go to source lib flow. No. Cadence. So let me show you the float contract. So for example, this is the float contract, by the way. Yeah, it's long. It's very long. But let's go back to the top and let's look at all the events. So public event float claimed. So here is the claimed event. Let me zoom in a little bit. So this float claimed event right here, you can see it has an ID and the host who hosted the event ID, the event image, the event name, the recipient, and the serial. And so we actually use all of that data on the float page um, in order to display the NFTs. So, for example, if you've ever looked at this page before, you'll have noticed that like the event info flies up to the screen, yeah, that's it uses this event image, it uses the name and the recipient, all these things to display it here. Oh, look, it's working again. There it is. Oh, well, I guess gone now. um, yeah, but you saw it for a second, I guess. So the image is saved as a string. So what actually happens is because storing images on chain is so expensive, we actually upload all the images to IPFS, which is a decentralized storage, and then that returns a hash or like a CID, which is a string. And so you can use the string to go look it up again. But we just store the strings in the contract since it's a lot cheaper. But that's like pretty much the standard in Web3. Can we emit a burning event? Yeah. So look, float destroyed right here. So public event float destroyed, ID, event host, event ID, and serial. So let's actually look that up in the code. Float destroyed. So you'll see that look, this is the NFT right here, which is the float, right? This represents a float. If you go to the destroy function, when you destroy it, it emits float destroyed, which is the ID, host, event ID, and serial. Yep. So you're right. Raven says we need custom animation on float site. Listen, Raven, if you make a custom animation, I will put it on there. Let me tell you. Jacob, don't highlight this message. Raven always makes fun of me because I highlight my messages when I talk. I would like to see another course on testing cadence. Sure. Yeah, that'll probably be a part of like the advanced course, Raven. But actually, I didn't announce this yet. But on Saturday, on Saturday, once the course is over, we're gonna review the Flovitar smart contract or a similar one because I think Flovitar might be too different. But we'll try our best. All right, so everyone good on events and pre and post conditions? Does events like make sense to everybody? Yes? Awesome. Cool. So as my, you know, because we're not going to really talk about events from this point on, my best piece of advice is if you're thinking about whether or not to make an event, the answer is always yes. So if you want to notify the public that something happened and you're like, should I make an event for it? The answer is yes. That you can never make too many events. Tech and I both agree on that very much. So listen to Tech and me. Woo! Okay, cool. Day 2, contract interfaces. So Becca, you might struggle on this part, but that's okay. Because this relies on some knowledge of resource interfaces, but YOLO exactly. So here we are. Um, So yeah, this isn't going to be too hard, only because this is really similar to resource interfaces. So everyone think back to your resource interface lesson when we do this. So Numini says the event is there forever. So yeah, once you emit an event, it's pretty much there forever. So Graphel, yeah, let's take a quick look at Graphel just to see it. So Graphel, this is their site. Yeah, so they bring all the events into like a storage and then they store it there pretty much forever. So I think it's called like they like mine the chain or something for events, and then that's where it is. Yeah, yeah, you can't see anything here. It's like, because it's like kind of secret, but it's like not really. Yeah, so anyway, if you're a developer, you want to look into Graphl, go here. Slight disclaimer, it's a little outdated half the time, but you can hit up their Discord and they're really helpful. Can an event be destroyed? No, 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 can't. Google found it for me. Yeah, true actually. Okay, cool. Let's go to the next part. So, contract interfaces. Let's just do it in code together. So let's delete everything. Actually, let's keep the NFT here. That's going to be helpful. And let's get rid of this event too. Oh, okay. And just to simplify things, let's return right away. So simplification. Woo. All right. So we have a simple contract, hello world, and we have an NFT resource with an ID and name, and we just mint it and return it in this minted. That's it, right? So let's talk about resource or contract interfaces. Sorry. So how do I want to teach? Okay, so before we do that, let's review our resource interface understanding. So remember way back to resource interfaces, we said there were two reasons for them. One, to require the implementing type to do something or to have something, and then two, to restrict access. So for this one, remember, like if I said, okay, I want this to have a public let ID with the UN64, then the implementer, which is, if we implement the INFT on this resource, it must have it as well, which it does, right? But if we were to say like public let poop, the string, then all of a sudden we have a problem because this doesn't have a poop. So we would have to take the poop and put it here, right? So now the poop is there. And now it's saying, well, we have to initialize it, but you get the point, right? So this number one means that if it's in the interface, then you have to put it here. Yeah. Trying to spice it up a little, guys, to keep it interesting. I know this can get somewhat boring. Um, anyway, so right, you get that, right? And let's say we have a function. Let's say it says, okay, you need to have a function that says read ID, and it returns a UN64. Then inside the actual resource, you have to have the function that says read ID that returns a UN64. The only difference is that inside the actual resource, you have to implement it, right? So you return like self.id, whereas in the interface, you never implement it, right? You can't put these brackets here, okay? So, yeah, right? Because in the interface, you never actually implement the thing, right? You never initialize the variables, and you never implement the functions. Okay, so let's keep that there for now. But this is very similar to a contract interface. So as you can imagine, public contract interface, I'm going to call it hello world. Now, inside of here, keep in mind that even though this like will look like a contract, it's not. It's a contract interface. So let's say in here, it's like, okay, you know what? Anyone that implements this contract interface must have a public var raven that's a string, right? Boom. And notice that there's no errors, right? It's not saying, hey, wait a minute, you have to initialize that. And that's because, right, you can't do this in an interface, right? You can't do this in an interface, right? So that's poor poor Raven. I didn't mean that. I didn't mean that. Everyone loves you, Raven. I was just kidding. Raven, you know I love you. So it's interface, right? So you don't actually implement the stuff. And same with, if we have like a public resource NFT, right? Well, with an NFT, actually, you do implement it, and I'll show you why. So with an NFT resource, let's say we want our resource to have a public let ID of UN64, and that's it. Okay, we don't initialize this at all because we're in an interface, so nothing is being initialized here. So if we were to deploy this for a playground, no one likes the playground. That I know. Okay, so if we deploy this, Oh my God. Please. Okay. So now that we deployed the interface, let's go back to account 1 and let's import I hello world from the second account, and we're going to implement it on this one now. I hello world. All right. Now, there's a problem. So it says contract hello world does not conform the contract interface I hello world. Now, why is this? Anyone have any guesses? Why is it giving us this error? Are we missing something? Var bot and what do you mean by that, tab call var bot? Oh, var not, yeah, exactly. Yep. So just like tab call and Raven said, the reason it's missing, or the reason it's giving us an error, is because Raven is missing. We don't have Raven. So we have to bring Raven over. Right? And then now it's saying, hey, we have to initialize it. So we have to say self.raven equals everyone loves you. It's true. See, no errors because it's true. And now we're good. And we even have like the public resource NFT with a public let ID UN64. We have that as well. That's right here in the NFT. It actually works totally fine. And now we're good. Right? So a contract interface basically says you have to have this certain thing in your contract. Now let's take it one step further, and this is where stuff gets really confusing. Okay, so just red alert. But let's say inside of our contract interface, we have a resource interface. So public resource interface, INFT. All right. And inside this INFT, it says, okay, you have to have an ID, a public let ID of UN64. All right. And then the resource has to implement it. So this works because the resource interface says, okay, you have to have an ID with UN64. And when we implement it on this resource, we have it. So we're all good. Okay. So the contract interface is happy. But something bad's going to happen here, right? So when we redeploy this and we go back to the first account, there's a problem. So you don't know the answer to this yet, but I'm going to ask anyway. Why is it that this is not right anymore? What's wrong with this line? Anyone have any guesses? And if you don't know, it's totally okay because we didn't, we didn't teach it yet. But maybe people have some guesses. What's wrong with this line? And I'll try and lead you there. In the contract interface, it's saying, okay, you have to have a public resource NFT, and it has to implement INFT. Now remember, INFT is talking about this one, right? It's talking about this. So inside of here, what's wrong with this? Is this the same thing as this one? No, it's not. Exactly. It's not the same thing. This one is talking about this resource interface, whereas this one is talking about this resource interface. And our contract interface, I hello world, is saying, okay, you need to have a resource NFT, which we do, right? We have a resource NFT, but it's saying it has to implement this one. So we can't have this. We need to have I hello world.inft. And now we're okay. Now, of course, if we wanted to, we could also implement INFT, which is this one. So we can do both. But the only required one is this one, because that's what the contract interface is telling us we have to have. So it's really important in Cadence to understand, especially now that we're at the end of the boot camp, it's really important to understand what types are talking about what, right? This type is talking about this one, whereas this type is talking about this one. All right, so that's a really, really important note to have in your head. And, this goes back way, if you remember all the way back to our first workshop, we talked about security and readability in Cadence. And this really adds to the security of Cadence, right? You can't mess up. Cadence won't let you mess up. It's telling you This is not the one I was talking about, right? We're talking about this one. So that's a really important thing to note. I love you, Cadence. I love Cadence too. But you even more, Numini. And let's see if what else do we have here that I wanted to go over. Resource interfaces in contract. Yeah, we did that. Okay, cool. So now we're going to talk a little bit about why pre and post conditions. Actually, okay, before I do that, let me do one more thing. So in the contract interface, I'm going to add a function called add. And inside, oh, I can't do that. Oh, I already messed up. So I added a public function called add, right? So let's deploy this, and we're good. And let's go back to account one, and we have an error. What's the error? You should all know this one by now. Why is it giving us an error? No add function, right? Exactly. So we have to add a public function called add, and in here, we have to actually implement it, right? And let's just say return x plus y. So I forgot to put x and y in here. I forgot to put that in the other one too. Okay, we deploy this. Okay, back, and we're good. Oh my god, I keep messing up. We have to put the return value here too. All right. So now we have to have an add function that returns an integer and takes in an x integer and a y integer. And so now inside our contract, it's totally fine because we have that exactly right here, and then we actually implement it. So this is where pre and post conditions actually become really useful. Because remember, I told you that in any interface, whether it be a contract interface or a resource interface, you can't ever actually implement the stuff. So if you have a function, you can't open these brackets, right? You can't put stuff in here. It's not going to work. And same thing with a variable, right? You can't ever initialize a variable. Say self.raven equals hello, right? You can't do that, right? But the exception is when you have pre and post conditions. So what you can do is you can open up these brackets and it's going to give you an error, but you can actually put a precondition. And in here you can say, okay, x has to be greater than 5 and y has to be greater than 5. Otherwise, say contract interface is not happy. Now there's no error. So you can actually shove pre and post conditions into contract interfaces or resource interfaces, and it's happy. So if we deploy this contract, thanks Playground, crap. Let's do this again. Deploy it. Okay, it finally worked. So let's say we put that in the contract interface, go back to our normal contract. Now the cool thing is that we're not forced to put this. We're not forced to put that here. So you don't have to put the precondition in this one, but it's still there behind the scenes. So if we deploy this contract, go into our script, and try and run hello world at add, let's say we run with 1 and 1. Try and execute this. Uh-oh, the contract interface is not happy. And you'll notice that we didn't even put anything in our contract, but behind the scenes, it's actually there in the contract interface. All right, so you can put pre and post conditions inside of interfaces. And the same thing goes for a resource interface, right? So inside read ID, what we can do is we can say, okay, in read ID, we want to say, the post condition is that the result is greater than 0. Otherwise, this is not a valid NFT, or greater than or equal to 0. Otherwise, this is not a valid NFT. And so if we were to call this read ID function, even though there's no post condition on this function, it's still there behind the scenes because of this resource interface. So I hope that makes sense to everybody. Yeah. All right. Cool. So now the question is, which we're going to spend the rest of today talking about, is, well, what's the point, right? Why would I ever go out of my way to make a contract interface? And the answer is that most likely in all your time of cadence, you're not going to be writing that many contract interfaces. In fact, you might not even write any. The point of a contract interface is to set a standard. So what I mean by that, well, we're on this section with contract interfaces as standards. So when you think about like the realm of the Flow blockchain, right? There's a ton of different projects that all exist on the Flow blockchain. There's Flowatar, there's Goated Goats, there's Floats, there's .find, there's I don't know, so many other projects, right? Some.place, tons and tons and tons of projects. And they're all NFT projects, right? And so it's really important for those projects to all be somewhat similar in how they're implemented. And the reason for that is because if they weren't, then places like marketplaces or Blockto wallet that display your NFTs or applications that deal with those projects contracts, they wouldn't be able to easily understand how to read and interact with those contracts unless they were all the same. So as an example, let's open up the Flowatar contract, right? In here, you'll notice that the Flowatar contract implements the non-fungible token standard or contract interface. But what's important to note here is that every single NFT project on Flow, they all implement the non-fungible token standard. So you could open up the Go to Goats contract, you can open up some.place, you could open up Flunks, any NFT project, they all do this. And the reason for that is because in order to be an official NFT project on the Flow blockchain, you have to implement this contract interface or this standard. And again, the reason for that is so that marketplaces or people like Blockto Wallet or wallets that have to display your NFTs, so they all have a standard way to do that. So let's take a look at the non-fungible token contract interface, right? So it's a contract interface called non-fungible token, and it says, okay, you have to have a total supply, you have to have an event called contract initialized, you have to have an event called withdraw, called deposit, you have to have a public resource that's specifically called NFT, it has to have an ID in it, um, you have to have a resource collection, and that collection must implement provider, receiver, and collection public, which all exist above, right here. Your collection must have an owned NFTs. It must have a withdraw function. It must have a deposit function, a get IDs function, a borrow NFT function. So all these things in every single one of these projects has to exist. So again, if we were to take a look at Flowatar, let's go to Flowatar. You'll see it has a total supply, right there. It has, we scroll down, and public resource called NFT. It implements non-fungible token to INFT. It has an ID. If we scroll down even more, we'll probably find the collection. Get a search for it, I guess. Right? It has the collection. And notice that it implements non-fungible token provider, non-fungible token receiver, non-fungible token collection public, right? All these things it has to have, an owned NFTs, a withdraw function, a deposit function. So I hope that this rant is helping you understand that the point of an interface is to make sure that projects are similar in the way they're implemented so people know what to call, right? Because whether you're working with Flowatar, whether you're working with Flunks or some.place, you always know that you can call collection.withdraw. You know you can. And that's really important when you're working with NFT with tons of different projects all at the same time. So yeah. So what if I didn't use a standard? Then Blockto and marketplaces probably wouldn't support your project because they wouldn't be able to understand how to read your NFTs. And for the record, by the way, all this interface stuff we're talking about, this is a much broader concept in computer science. You'll see this everywhere, right? In object-oriented programming or just tons of other languages, but we're talking about it specifically in blockchain terms. But this is a general computer science concept of interfaces that the point of an interface is to standardize or help other code understand what exactly can be called on your code. Yep. So yeah, that's my rant on standards. And if you ever have any questions about that, let me know. And I'd be more than happy to help out. Awesome. Awesome. Oh, and one more thing I want to mention. I sometimes forget to mention this, but if you didn't already kind of get this, in your contract interface, if you have a resource interface, you don't have to also implement that resource interface in the implementing contract. So you'll notice here that like this is kind of a bad example because I did, but you can actually get rid of it and it's totally fine. So even though inside of our contract interface we have a resource interface, you don't have to copy that over at all. And again, that's because the one that it wants you to refer to is the one that lives in the contract interface itself, right? So this one. And so if we were to look at Flovitar, for example, the collection implements non-fungible token.provider, and nowhere in here will you find a provider resource interface because it doesn't re-implement it. So that's just an important thing to note as well. Yep. So that's everything. If you want to get maybe a bit more information, you can feel free to read about it. Yeah. And the quest should be pretty straightforward, I think, now that you know that. And in the last day, which is on Friday, we're going to talk about finishing our NFT contract. So what we're going to do is we're going to take the whole contract we built on last Friday, and we're going to make it an official NFT contract, which now you know means we're going to implement the non-fungible token standard. And then you will have an official NFT contract on Flow blockchain, or at least on Flow testnet, because mainnet is not open yet. Yeah. So thanks everyone. I'll see you on Friday, and on Saturday I'm gonna announce this. But on Saturday, because last bootcamp we got some feedback that people wanted to actually see like all this learning in live action. We're going to on Saturday walk through a live contract so that you can all understand it. So Boaz, thank you very much. I'm gonna send I actually already did the float earlier, so I'm gonna send that right now. And yeah, so the password is Jacob Rocks, all lowercase, all one word. So Jacob Rocks. True fact, by the way. True fact. Oh, I have to hold on. I have to make it claimable. 1 sec. It's currently off. Let's see. Once this turns back on, who can get number 0? No, Block's making me log back in. Uh-oh. Block's is gonna get wrecked. Come on. Also, who wants to see a sneak peek of our NFT Minter platform? It's laggy on my computer because my computer's slow, but it's not actually this laggy in real life. But yeah. I think it's because I'm streaming. I think that's why. Nice. I got my float. I got what? I got number 0. That's the first time I've ever gotten number 0. That's funny. Look, I'll show it in Discord. Boom, number 0. Get wrecked. Yeah. So this is the latest version of the NFT Minter platform, and we're trying to get this out in the next couple weeks. Really, really hype about it. Really hype. All right, everyone. Don't want to keep you too long. I know it's late on a Wednesday, maybe really early. But anyways, love the UI. Oh, thanks, Buzz. Have a great night. Thanks for tuning in. See you all on Friday. And if you can't make it on Friday, then try to make it on Saturday where we review the contract. So peace out, everyone. Have a great night, and see you on Friday. Bye-bye.
If I could have lived past Scion passive somehow, which I actually have my E, so maybe, then I definitely would have killed Zach. Zach like was doing nothing. He's so weak. If I had Zony zones there, they're fucking doomed and blown. Yeah.
I see your 3 and 4 Aiden.
Yep. I got autofill top. But honestly, I might just become a Swain main out here. He's so OP right now, and I played him once and fucking trolled. But I finally learned how to like actually use him, and he's pretty good.
He's so good.
Bro, this ult is like the most hideous shit I've ever seen in my life.
I know. Oh my gosh, and then I get ripped at this though. Get in here, Nocturne, and save my ass. How is my ult still going? Does anyone have a fucking smidgen of a clue? I was like waiting for it to end for 45 minutes there.
You know you can pop your ult for damage, right?
Yeah, I think I popped it in the middle of that fight on Scion, but